Okay, let's continue discussing maybe a couple more elements, because there is something that we have to do that I haven't quite taught you yet. So let me bring back the periodic table. Okay, let's do maybe a vanadium 2350.94. Okay, so that's vanadium 2350.94. Okay, so vanadium, you've got 2350.94. okay, as I said, this is our atomic number and this is our atomic mass. Okay, the reason I particularly picked this, because there's more elements like these that you might run into that would pose a problem, because I haven't quite told you another technique. Okay, so let me go ahead and pick my green, and you notice, why is he going for green? I thought he used green for striking those decimal places. Well, that's precisely my point. I am not going to strike it, because when you see this first number right here past the decimal place, if it is 5 or above, that is 5, 6, 7, 8 or 9, then you're not going to strike it, but round it off to a nearest whole number. Okay, so this number right here is a 9, so we can't treat it as 50, but instead we are going to round it to a 51. Okay, you do this only if the specific number that is immediately following the decimal place is 5, 6, 7, 8 or 9, then you can't just treat it as 50, but you should round it off to the nearest whole number as 51. So going with that analogy, the atomic number rule will never change because it's a whole number. So vanadium's atomic number is, actually let me erase this because it's still following a green color. So let me go back and maybe change to a red, maybe something really bright that you can see. Okay, so vanadium, okay, vanadium's atomic number is 23, so it's got 23 protons and 23 electrons, right? Okay, now as I said, this is where you have to adjust the rule. You can't simply strike off all the time, and that's kind of the abnormality and why chemistry is abstract. Okay, now you got to pay attention to that. So the number of neutrons would be 51, not 50. 51 minus 23, that is 28. Okay, 28 neutrons. So if you recapture everything and then summarize it, okay, so vanadium has, let me put it in a box so it doesn't get mixed up with the rest of the stuff. It's got 23 protons, 23 neutrons and 23 electrons and 28 neutrons. Okay, so I'm going to do 2 examples in a row, and I'm going to pause the video each time and then give you time to work it out, and then continue watching the video, see if you got it right. Okay, all right, let's bring back the periodic table and let's pick another element. Okay, let's pick lithium. It's 6.941. 6.941. So it's lithium 6.941. Okay, and again 3 is our atomic number. Okay, and the fraction 6.941 is our atomic mass, right? So do this problem. So tell me, I'm going to change it maybe to a different color just to write my exercise here. Determine the number of protons, number of electrons and number of neutrons for this particular element. Pause the video at this point. Okay, if you have to, rewind, but don't forward, rewind and see what you have done. But if you paid attention at this point, you would be able to solve this problem. Pause the video and then do your work, and then come back, continue watching the video to see if you did it right. Okay, good. Now pause. All right, assuming you have done it right. So lithium 3, 6.941, and this is the atomic number. So I'm going to switch colors here, maybe pick a red again. So lithium has an atomic number of 3, so it has 3 protons and 3 electrons. But keep in mind, this number right here is a 9. So we can't just round it off to a 6, but instead we should round it off to a 7. So let me go back and switch it to green so I can highlight it. So this technically should be read as a 7, simply because the number that's following immediately after the decimal is a 9. As I said, if it's a 5, 6, 7, 8, or 9, you should round it to the nearest one number higher, so it will be 7 instead of 6. So the number of neutrons, let me erase this because I want it to be in my blue. So let me go back, get blue, and so my number of neutrons would be 7 minus 3 would be 4, so it's 4 neutrons. So if you have to go back and summarize everything, it will be lithium has 3 protons, 3 electrons, and 4 neutrons. Does that make sense? All right, here's our next example. So all right, let's pick one that is potassium. It's 1939.10. 1939.10. So it's potassium 1939.10. I mean, as always, the atomic number is not as confusing. So let's go get our red color. Okay, or actually let's leave it in blank because I want to write my questions here. So how many, okay, number of protons, number of electrons, and number of neutrons does potassium has? Go ahead and pause the video, work it out, come back, continue watching the video, see if you got it right. Okay, so potassium 1939.10. Okay, you probably got the first part right because it's always easy for students to master the number of protons and electrons. So I'm going to go get my red color. So if you have done it right, this is what you should read. Potassium should have 19 protons and 19 electrons. Okay, and then your number of neutrons should be, let me go grab my green, and if you see, this number right here is less than a 5. That is, it's not 5, 6, 7, or 8, or 9. So we can round it off. We can not count them and strike off. So we will be left with a 39. So now let's go get our blue and then let's do our math. So the number of neutrons then would be 39 minus 19. I will leave you with 20 neutrons. So if you summarize everything, okay, summarize everything, that means we should have, for potassium, we should have 19 protons, 19 electrons, and 20 neutrons. Does that make sense? Okay, I've done two different kinds, so you could probably expect a quiz or a homework problem based on this concept. Okay, all right, let me pause here and then we'll continue the sequence in a nearby video.